Welcome to this session. Thanks for joining us. I'm Apurv Saxena. I'm the product lead on Cloud Machine Learning team.
I'm Sarah Robinson. I'm a developer advocate on the Google Cloud Platform team.
And here we are today to talk about how cloud machine learning can transform your customer service experience. But before I get started, let me see how many people were listening to Diane Green in yesterday's keynote. So as a show of hands, I'm going to ask you how many products and features we released last year in 2016. Those who believe we released less than 200, raise your hand, please. Between 200 to 400. Yeah, a few. About 1,000. Now we around between 500 to 600. That's the number. So we released more than 550 products and features last year alone. And today, at the conference, we released more than 50 of those. So great momentum for us. And this is what we are going to talk about, how specifically in this session, there are three things I want you to take away. Number one, I want you to understand some of the new products and features that we have launched and how they can transform customer service. Number two, we will walk you through a case study where one of our customers, Ocado, is using some of these tools to transform customer service for their customers. And the third one, we will talk about a PwC case study where a customer is building an end-to-end field service solution.
So Apurv, as a product manager, you probably get a ton of feedback coming from all sorts of channels.
Yes. In fact, at Google across the board gets more than 10,000 service requests, customer service touch points on a single day. And so as a result, we believe great customer service is an important part of a great product experience. So we monitor our channels, not only in the traditional email and phone calls in terms of customer requests, but we also monitor Facebook, Twitter, and so on and so forth. But to get a differentiated customer service experience, it's not only important to monitor all the different channels the customer can reach you, it's also important to make sure that the customer request journey is differentiated across the life cycle.
And what does a typical customer journey look like?
So let's take an example. Again, it varies by company, but we just did a very high-level view of how it could look like in a situation like this. So on one side, you have customers' touch points across different channels, as I said, whether it could be a phone or an email or Twitter feed coming in. The very first thing you typically do when a customer request comes in is try to understand who the customer is. So typically you will tap into your CRM system to understand who the customer is. The next level is not every customer request can be prioritized at high priority. So you try to understand what the priority of the request is. And then you route that request to the appropriate CSR. So if you think it's a pretty simplified view, but across these 4 steps, you still have huge opportunity for machine learning to make an impact. Number one, on the side, at the left of the funnel, you will see that most of the customer requests are well understood if they are coming from email. Phone is completely handled differently. How do you make sure if I can transcribe all my audio calls into text and then run some analysis, there's a huge opportunity there. Number two, typically you can route your customer request without even understanding what's in it. What if you can use natural language to understand and parse what's being said in the customer service request? And the third, if you want to route your customer service request, if you know if it is about shipping or if it is about pricing, you can route it to different CSRs. Again, huge leap of improvement in productivity if you can route it intelligently. So those are the opportunities. So at Google, we have provided you a set of machine learning portfolio that helps you tackle a lot of these problems. On the left-hand side, we have what we call pre-trained machine learning models, where you don't need a data science degree to actually use some of these models. These are RESTful APIs that you can call using simple line of code. And what it helps you do is understand what's in an image or audio or video. On the right-hand side of this spectrum is if you want to build a custom model for your own particular need, if you want to do a text classifier to route your tickets differently, you probably will use an open source deep learning framework like TensorFlow and run it on the cloud machine learning engine. And that's the whole spectrum that gives you the opportunity to build to your need. So to talk about each of these key products that are useful, I will hand it over to Sarah to walk you through the products.
Thanks, Apoorv. So I'm going to cover the Cloud Speech and the Cloud Natural Language API, since those are particularly relevant to customer service. We'll start with the Speech API. How many of you have used the OK Google functionality on your phone? Anybody here? Looks like a little more than half. So the Speech API essentially exposes the functionality of OK Google to developers and lets you do speech-to-text transcription in over 80 languages. So here's an overview of the features of the Speech API. You can transcribe text in over 80 languages and variants, and it supports both batch and streaming modes. So you can send it a complete audio file. You can also send it a stream of continuous audio, and it'll transcribe that audio as the stream is coming in. It can detect inappropriate content in your audio, and then you can, once you've got the text, you can analyze it with other Google Cloud machine learning APIs, which I'm going to talk about momentarily. So this is what a request to the Speech API would look like in Python. So you create your service request, and there's a couple different things you need to pass the Speech API. You tell it the encoding type of the audio. Here we're using linear 16, the sample rate in Hertz, and then you pass it the language code. If you leave this parameter out, it'll default to English. Otherwise, if you're using a language other than English, you just need to tell it the language code of the language you'd like to transcribe. And then you pass it either a Google Cloud Storage URI of your audio file, or you can give it a local file to transcribe. And that's all you have to do. So the beauty of these machine learning APIs, I like to call them friendly machine learning, is they give you access to these pre-trained models with just a single REST API request, so you don't really have to understand what's going on in the underlying model. So that's the Speech API. So with the Speech API, we're transcribing audio. Once we get that text transcription, we likely don't want to stop there. There's probably more analysis we want to do on it, especially in the customer service industry. Once we get our customers call, maybe it's a voicemail, we're going to want to do more analysis on that text, and that's where the natural language API comes into play. What it does is it lets you extract entities, sentiment, and syntax from text. I want to take a deeper dive into those three features that it lets you do. So for the entities example, I'm a big Harry Potter fan, so I've taken the sentence about J.K. Rowling from her Wikipedia page. And let's see what the entity extraction endpoint will give us back if we send it this sentence. So it's able to extract these 5 entities, and it's going to give us some JSON data on each one. And one thing you'll notice here is that those first 3 entities are actually all the same thing. They're actually just different ways of saying J.K. Rowling's name. Robert Galbraith is actually a pen name she used for a later book series, but I won't get into that. So they all point to the same entity. So for the entity data, we get back the name, the type of entity it is, she's a person, and then some metadata on her. So the API won't necessarily return metadata if it's an entity that doesn't have a Wikipedia page, but in this case, there definitely is a Wikipedia page for J.K. Rowling. So it'll give us the MID, which is an ID that maps to Google's knowledge graph, so that you can then call the knowledge graph API to get more data on this entity. And then we get the Wikipedia URL for her. And the other JSON responses look similar. For British, it maps it to a location. We also get the MID and the Wikipedia URL. And notice that the Wikipedia URL points to the United Kingdom Wikipedia page. So if instead the text said UK or United Kingdom, it would still point to the same entity. And then for Harry Potter, it looks similar. We get the entity type as location. That should actually be person. It's a mistake. And then it points to the Harry Potter Wikipedia page. The second thing that the natural language API lets you do is analyze the sentiment of something. So something this is useful for is customer feedback. In this case, this is something that might be on a restaurant review. The food was excellent, I would definitely go back. So it returns 2 values for us to understand the sentiment. The first is magnitude, and this tells us the overall strength of the sentiment, regardless of whether it's positive or negative. And this will change based on the length of the text. It can range from 0 to infinity. This text is pretty short, which is why we get a pretty small number there. The score value is going to tell us whether it's positive or negative. So this ranges from -1 to 1, and we can see that this is a pretty positive statement, so it's almost all the way at 1. And then the final feature of the Natural Language API is analyzing syntax. And this gets a bit more into the linguistic details of text. And this visualization is actually pulled from the product page for the Natural Language API. So anybody can go here and try it out, create a visualization with your own text without having to write any code to get started. There's a bunch of data it returns here on the syntax of your text. So the sentence we have is the Natural Language API helps us understand text. And let's start with that top row, those green arrows. That's what we call a dependency parse tree, which basically tells us how the words in the sentence relate to each other, which words depend on other words in the sentence. That second row is the parse label, and that's basically the role of each word in the sentence. So we can see that helps is the root verb, API is the nominal subject. The third row is just the raw text, and then that purple row is what we call the lemma, which is the canonical form of a word. So we can see that the word is helps, but the lemma is actually help. So if you want to count the occurrences of a particular word, you can use the canonical form so that helps and help don't count as two different words. And then in the red row, we get the part of speech, verb, noun, adjective, etc. And then finally, we get additional morphology details on each token in our sentence. So that's what the syntax annotation looks like. So with the speech and natural language APIs, they work in many different cases, but there may be situations where your system has a lot of different custom data, custom entities that you're looking for. And in this case, you would want to use something to build and train your own models. And I'm going to hand it over to Apoorv to talk about Cloud Machine Learning Engine.
Sounds good. Thank you. So imagine I was talking about a customer service request, a customer phone call coming in, talking very agitated and saying, hey, my shipping was not delivered. So again, using speech API, you have transcribed that audio into text. Using sentiment analysis, using natural language API, you have figured out this is a very negative comment. As a result, your system so far has identified this is a very high priority call that you need to route. Next thing you need to know is what kind of request it is. Is it a shipping request? Is it about pricing issue? It's about support issue, so on and so forth. And this is where your cloud machine learning API, the cloud machine learning engine comes in. So to do this classification of whether a particular request is a shipping request or a pricing request, you will use what we typically call text classification. Text classification is pretty simple. What you do is look at a document, or in this case, email or any audio converted to text, and classify it into a label, a predefined label that you have relevant to your use case. So a classic example, sentiment analysis essentially is an example of text classification. What you're doing is looking at a document and classifying whether it's a positive document or a negative document in terms of polarity. Same thing with document classification. So you can not only just do a particular document classify as one label, you can say this ticket is about shipping and pricing. So because a customer can talk about more than one subject in a particular email. So that's the example of text classification. And building a text classifier traditionally required a pretty detailed understanding of the underlying algorithms and the infrastructure. With TensorFlow and Cloud Machine Learning Engine, all this is simplified to a significant degree. A typical text classification on a customer service would look like this. There are two steps involved in building any classifier. One is the training step, and another is the serving step. In the training step, what you're doing is you're taking a set of labeled documents. In this case, it will be service requests labeled as shipping or pricing issues or customer service issues and so on and so forth. You feed that in and train a classifier. And the way you train the classifier is basically extract out key features that you train the classifier on. In this case, the features could be words or bag of words or a sentence, so on and so forth. And that you feed your classifier and train your model. And once you have trained your model, and if you got the results that you expected in terms of your test data, you then use that trained model on a cloud machine learning engine to serve for your production environment. In a production environment, it's pretty simple. You get a new service ticket. You send it to the classifier being served on the cloud machine learning engine. Out comes the label. In this case, whether it's a shipping request or a pricing request, so on and so forth. So this is, again, we haven't gone to typically a text classifier using TensorFlow because TensorFlow provides a set of very sophisticated libraries, helps you do the pre-processing and the post-processing on text very easily. So I'm hiding a lot of those details here, but no more than 80 lines of code, you can build a whole classifier. And so, for example, in this case, the very first step is you can specify the model you want to use to build your classifier. So here in this case, I'm using a bag of words. Bag of words doesn't take into account the order of the word. So for example, it will take for shipping requests, as long as there are words like shipping, delivery, date of delivery, and so on and so forth, it will classify that request as shipping request. And for pricing, if there are words of pricing, discounts, and so on and so forth, that will use it to classify, the model will use that to classify it as a pricing issue. So that's the very simplified bag of words. You can try out different models as per your need and the accuracy that you need. And again, this TensorFlow allows you to sort of change the model in very simple ways. And once you train, the first thing, once you specify the model to use, you train your model, and then you run your, once you've trained the model, you run the prediction. And that's how, and then typically you will run this predicted model or a trained model on a cloud machine learning engine. So that's it. Again, very simple. You went from step one, speech API using language API, and now text classification to route your ticket.
Thanks, Apoorv. So we've heard about a few products that can help us with this, but to get a really good understanding of it, it'd be good to see a real customer use case. So I'm going to bring up Dan from Ocado. Everyone welcome Dan. Hi, Dan. Dan is the head of data at Ocado. And he's been in IT for 20 plus years and always been passionate about data driving businesses forward. So Dan, could you tell us a little bit, give us some background on Ocado and explain the problem you're trying to solve with machine learning?
Sure. So this slide kind of says it all. We're an online supermarket. We're based only in the UK, so quite a few of you probably won't have heard of us. What it doesn't tell you is, in fact, we're the world's largest dedicated online grocery business. We have about 500,000 active customers and a revenue of $1.5 billion. We've been around 17 years. I think that's the time that Diane said as an average yesterday, which was a bit funny, and have basically innovated and disrupted the grocery market in the UK since our inception. We actually have 1,000 engineers. So we're more a technology company who run retail and operation logistics businesses than a pure play retailer. And those operations are kind of part of the model. We run what we call CFCs, customer fulfillment centers. These are large-scale automated warehouses. By large scale, I'm talking about 4 football pitches as a footprint, 4 stories high, with about 20 miles worth of conveyor belt within them. They basically take product in from suppliers on pallets, and then they distribute them out at the other end as individual items for customer orders. They process about 10 million items a week and complete an order every 2.5 seconds. We have 2 of those. They're what we call our kind of legacy ones now, because as part of disrupting the industry, we disrupt ourselves. And we've recently created a new model of warehouse. It operates as a hive, a 3-dimensional dense storage grid with robots running over the top of it, which basically give us increased efficiency and increased accuracy. And all this technology and all this operation efficiency is all because we want exceptional customer service. The grocery market is extremely competitive around the world, but in the UK especially. And you need a compelling offer to the customer, and you need it to be consistent and reliable, because if you get it wrong, they will move. Our warehouses allow us to offer a wider range than anybody else, about 50,000 grocery lines, and we achieve a 99% fulfillment rate on that to the customer. But, you know, it doesn't always work. And as much as we've applied machine learning inside of our warehouses to improve the way that product flows and is laid out, and as much as we're intelligent about segmenting and personalizing our service, when we get a customer problem, it always comes down, as Apoorv said, to emails or voice. And when you get to a scale that we're at now, dealing with those emails can be a challenge, and that's where we hoped machine learning would help us.
So how are you using natural language processing and machine learning and specifically Google Cloud Platform products to solve that problem?
Okay. This is a typical contact center, i.e. it was our contact center. An email would come in from a customer. It would go behind the queue, and eventually it would get to the front and be processed. You can see that regardless of the type of email, regardless of the importance and the sentiment, that queuing system just worked. Now, we get about 2,000 emails a day into our contact centers, and we resource our contact centers to deal with that. Where it becomes a problem is if we have a road network problem, it's the UK, we get bad weather, then actually that operation can slow down, and the emails can double, even triple. And so we wanted to come up with a way to basically prioritize so we could get rid of the queue. And as Apoorv had explained, that's kind of bringing structure to these emails. So the idea here, I love your website. These are typical emails, we have to say. I have children, so it's easier for me to do shopping online. That is classified as feedback, it's positive, and that's how we are able to then take that forward. Now, we used Natural Language API initially, and that did some great work in the classification and really good in sentiment. But the structure of our emails and the language our customers used means that we need a bit more of a bespoke model. And certainly the tags we want applying are very much fitting to our business. So as Apoorv had talked about, we thought, well, we'll look at using TensorFlow. We actually store all of our customer emails as an archive. We have a corpus of about 3 million emails stored. They were actually all stored on premise, and before we pushed them into GCS, we had to do a load of data prep. We wanted to remove all of the personally identifiable data. People do put credit cards, a bit like the demo today, you know, people can be a little easy with their information. So we ran some pre-processing, and once that had been stripped out, we tokenized it, so we kind of retained the meaning. We pushed that into GCS, and then basically ran a training of a model, and once that had been built, we, as Apoorv had suggested, put it into Cloud ML, and it now sits in front of our contact center and in real time receives the email, works out what it believes the subject matter is, what the sentiment is, what the priority is, and then pushes that back into the queue in the correct order. Basically, the model is a convolutional neural network. We have a word embedding layer followed by 2 parallel convolutional layers. We have a performance measure of 0.8, and the model was trained using word2vec as an initialization into the word embedding. We found that it worked really well on our corpus, and so we retained that, and was trained with a sigmoid cross-entropy loss over 20 epochs.
So how has implementing all of this machine learning functionality impacted your business? And maybe you could share any lessons you've learned throughout the process.
Yeah, sure. I was a bit quick on the click now, wasn't I? We put this in December, ran it in parallel basically to an all contact center queue, and we got some stark results. We were 4 times quicker at responding to negatively sentiment flagged emails than we were responding to the positive ones. So that was brilliant. So there was a definite distinction and differentiation there. And actually, as a base level, we were 3 times quicker at responding to those negative emails than if we hadn't applied filtering. So that was fantastic. Ironically, we haven't actually had a bad day since, so we haven't got a measure for what it does when we spike, but that was some fantastic results. And then as part of kind of better data, we actually found out that about 10% of those emails don't require any human interaction at all. They're kind of things like thanks, something like that. And if we auto-close those, then we can save, redeploy 4 full-time employees in the contact center, which is going to save us sort of around about £100,000 a year. And as the model itself only costs us £1,000 a year to run inside of Cloud ML Engine, that's about a 10,000% ROI.
That's huge.
It's huge. But those weren't the only things that kind of came out of it. I mean, obviously, it would have been great if that was all. But we did have some key lessons, as you asked. Firstly, we learned that we had to define our success criteria really well. This was actually the business and the development team for the contact center who came to us with the problem. And they were using measures like time for first response and things like that. Actually, what we found is that wasn't a great measure because it ignored the sentiment. It kind of ignored the long-term compounding. If it's my first issue, does it stop me shopping? No. If it's 2 or 3, yeah. So we had to work with them on getting better measures so we could actually tell if what we were doing was better. The other thing we found is be really careful when you kind of define your control groups and run A/B tests. When you're playing about with customer service, you don't want to get your test wrong. And you want to identify as soon as something might be wrong. And then the other thing was the initial feeling that this was all about contact center efficiency and headcount actually was not borne out either. By better data, we're now able to spot when products are starting to behave abnormally from a refund level. Sometimes that's something we do operationally to do with the way we've received or store product. If we respond to that quicker, we can reduce refunds going to customers. Refunds are basically bad products, so that's a great customer service benefit. And we can also respond to people going, I'm not going to be in, please cancel. And that means we can free up resource on vans and use less picking, pick less product, less waste. And then the better data also we can then extend out into our lapsing model. We now understand not just you contacted the contact center, but it was positive or negative, it was about a product. And that helps us build better lapsing models because now we know the contact. But then more than anything, and it's a relatively soft benefit, we now really understand how to build these machine learning models, how easy it is. And with the right kind of thought, it's kind of opened up vast opportunities for us to work on this.
Definitely. So what's next for Ocado? Do you have any future plans for more machine learning
Oh
functionality?
yeah, yep. So this is only the beginning really for the contact center piece. We'd love to apply this to social networks as well. Contact center would love us to be able to pick up trends from there. We want to go more into conversation as well, so more on the speech side, could be on the retail side or from a customer service point of view. We're also looking now at deploying machine learning models for demand forecasting. Our forecasting is great at the minute. We only have less than 1% of sales as waste, but we think we can get better. And so the opportunities are vast within the operation.
Great. Thank you so much for sharing your use case.
You're welcome.
Thanks,
Thank
Sam.
you.
Thank you. So next I'd like to bring up Apoorv and Rajiv to talk about PwC, another customer use case.
Dan, this totally changes your perception of a grocery store, doesn't it? Like, how many times do you think machine learning and is being used in such interesting ways? And this is unique in a way because not every customer that we work with has a data science team, and I'm privileged to have that head of data science here. But What if the customer doesn't have a data science team and want to achieve the same set of impactful results? And this is where our partners such as PwC come in. So to talk about how customers are working with PwC to build an end-to-end solution, I'll hand it over to Rajiv to talk about it.
Yeah. Thanks, Apurv. So I'm going to talk about one of our customers, Oscar Larsen, and how we help them with machine learning, how we help bring optimization to their business. But to set the expectation, I think Google has a great technology stack across all kinds of things. And I always joke with my friends that Google's stack is good because it can recognize Indian names in the voice recognition thing, which is very hard to do. And in Oscar Larsen is a company that's a PwC client, and they service gas stations, and they're one of the largest such service companies. And they have a huge challenge across different parts of their customer support organization. They have a challenge across how do you optimize recording of the calls that come in from different gas stations about what might be down. How do you make sure that the field engineers who go out there have all the data that they need, they have all the right equipment that they need, the parts, so they're well equipped and they don't have to do a return trip. And at the same time, we also wanted to analyze how we solve the problem that parts and other such inventory are not stuck out on the trucks of these field engineers, and they're using the right things for the right solutions. And Larsen, as a company, they wanted to scale from being a dominant player in 5 states to grow across the country. And what PwC was able to do is we were able to bring this business data to kind of train the machine learning algorithms and use the Larsen data along with the proprietary data that we were able to bring to build them a solution that could help them scale. And the way we did this, so we kind of, when you look at the system that we built for Larsen, essentially every time a new call comes in at the left side, and initially, we first try to extract whatever useful concepts and entities that we can extract from there. It's a little bit like one of the slides that Sarah had earlier, where we use the Google Cloud NLP API to extract whatever concepts we can get. And we also want to extract whatever sentiments that we can extract from them. It's slightly different from a problem of trying to disambiguate whether J.K. Rowling is the right author or not, when you have to deal with statements like, hey, my pump is down. It is a positive sentiment statement, but you have to try to analyze why is the pump down, what could the problems be, and that's what I'm going to show you as a demo. So to analyze the problem that comes in, we take all of the data that we have access to from Larsen. They get over 50,000 support calls a year. And they've been doing this for over 10 years. So there's a huge data set that was available for us to use as training data. And we also look at what parts were actually sold to the customers to fix different issues. And so we know that a problem came in, a certain part was used to fix it, and we use that as training data to figure out for future problems what kind of parts might be relevant. And using that, the ML system that we built, it recommends 3 solutions. Anytime somebody calls into Larsen and says there's a problem, it figures out who's the most qualified engineer, who's the engineer who knows how to fix that type of fuel pump or that type of point-of-sale terminal. It figures out what are the right manuals and documents that he might need on the ground to refer quickly to fix that issue. And we have all of those stored in Google Drive, and the machine learning automatically in real time links these Google Docs to the context. And the last part, which leads to the most cost saving for Larsen, is how it recommends the most relevant parts. So I'll show a quick demo of this. If I can switch over to the other screen. So,
I could be the field engineer right now.
yeah, well, we Indians have as many machine learning experts as we have gas station owners. So, so for this context, let's assume Apurv is a gas station guy who really doesn't know much about what the problem could be in his gas station. And this is what 90% of the problems that the Larsen customer support team looks at. You know, they could get a problem as simple as something like, just my pumps are down. And in most cases, these people don't know how to describe anything more than that. They have no clue what makes up a pump. I've had an education in this in the last 6 months. I've been forced to study this, but most people don't know. So the system figures out from a historic pattern of all of the problems, and it does cloud NLP on the fly to first figure out, hey, are all the pumps are down? Are they down on diesel pumps, unleaded pumps? It tries to get some more context. And if I say, for example, all pumps are down on unleaded, and then it understands that, hey, if it's a problem with just one pump, then it's probably something to do with parts that make up a specific fuel pump. And then it looks at things like breakaways and hoses and things like that. But if it's something to do with a lot of pumps, then it's probably something to do with communication to the pump, a motor, or something like that. So at first, it picks up, it also has a Google Map API integrated with it, so it picks up the location, it picks up where Apurv is calling from. He's definitely not calling from New York, but that's a real gas station in New York. And once he confirms his location, it picks up what type of gas pumps there are in that location, and then it diagnoses the issue to say that it's probably something to do with a motor or a filter, and it now sends this information to the field engineer who's been assigned to that case. It also picks a field engineer who is equipped in fixing motor or filter types of issues. And I can show you a little bit more under the covers of what's happening. So this is a simple representation of the recommendation engine that we've built. And so when that chatbot looks at the back end, it first tries to figure out what's the equipment on that site, and then based on recommending the issues, let me just refresh this. Okay. So it first analyzes that particular site and figures out what type of equipment there is on that site. And once it understands that, it goes on to try to analyze the problem. And this is where we're using TensorFlow. And we have a single-layered neural network we created a single-layered neural network to solve that problem. And once it figures out what could be the different equipment that could be that could be causing the fault, it creates a simple Bayesian probability analysis of that, and then assesses that it's probably due to a motor or a filter fault. Then the hardest part of this product was to try to figure out what's the right part that could solve that issue. And this is something that we're picking out of literally several 100,000 parts on the fly. And once it finds the right part, it also recommends the right documents that that field engineer would need to refer to fix that issue on site. We can come back to the slide.
So I think one thing I'm sure the audience want to know, what is the infrastructure and what are the technology choices PwC made in sort of building this solution? So could you tell more about that?
Yeah, sure. So this is what our architecture looks like. And we chose GCP primarily because a lot of the tools that we needed, we've tried a lot of different tools. And for example, if you look at the bottom of that slide, where we have all of the NLP and ML components. So we use the natural language API, and we use the cloud machine learning API and TensorFlow. And when we have a lot of these call records, a lot of these are not entered in full sentences. These are field engineers who are entering stuff on their phone. It's broken language. It's a lot of code words and item numbers and part names and things like that. So it's very hard to process that type of data with just a cloud, with just a natural language processing. And because there's a good tethering between the NLP API, the machine learning, and creating a neural network and executing it on TensorFlow in the Google framework, we chose that platform. And on the right side, you can see the legacy data, which was the data set that Larsen had for over 10 years. And we migrated that data to essentially a cloud SQL database. And we use Firebase on top of it, along with BigQuery to create indexes that we can query. And the front end is all built we have different apps for the dispatcher, we have apps for the call center people, field tech people. These are all Android apps which all access code through App Engine. So that's the reason we chose GCP was it really provided all the elements we needed from the front end to the back end to the machine learning piece.
Thank you. So to wrap it up, I think, as you can see, if you want, thank you. So as you can see, if you are a customer who has a data science expertise in-house, you can directly use our products as is. If you want to build an end-to-end solution, you can work with our SI partners such as PwC to build an end-to-end solution tailored to your needs. So in terms of external resources, these are the places where you can find more information.